Thank you for joining me for our session about the Intuit Analytics Cloud. My name is Tilman Brockhaus, and I'm going to be telling you about what the Intuit Analytics Cloud is, Intuit's big data platform, some key practices in how we plan, implement, and operate the Intuit Analytics Cloud, and also information about the architecture of our big data platform. Feel free to reach out to me. You have my contact information here, or follow me on Twitter. I'm with Intuit, and you guys may know Intuit from three of our big products. We offer TurboTax for tax preparation, QuickBooks for bookkeeping, and Mint for personal finance. We have tens of millions of users for those products, and you probably noticed all of those products are financial products. That means that one of the most important things in my job and our job at Intuit is to keep the users' data safe. That's the most important thing, that the users trust us with their data, so we can then use their data to make their lives easier. And by bringing all that data together from different users and different products, we can gain insights that will allow us to unleash the power of that data to make their lives easier. Intuit is a 30-year-old company. We were founded in 1983. And over the past 3 decades that Intuit has been around, we have acquired a number of companies. So when you have that situation, when you acquire companies, you will inevitably end up with silos of data, siloed data that you can't work across. And that's why Intuit created the group that I'm a member of, the Intuit Data Engineering and Analytics team, or abbreviated as IDEA. And our job is to bring all the data from all the different products together in one single consistent platform, so we can make use of that data and use the data to make our products better and make the lives of our customers better. So what is the Intuit Analytics Cloud, the IAC? You see a depiction of it here. You start at the bottom by ingesting data either in real-time streaming mode or in batch ingestion. You bring that data into the raw source data layer. Then we operate on that data. We augment the data. We transform it. We enrich the data. And then we offer a real-time data layer that our data-driven products can use to access that data in real time through APIs using services like Business Lookup Service, Unified Profile Service, for sharing information about users, so users don't have to enter their information more than once into Intuit products. Personalization, so we learn how users use the products and make the flows better for them, and also A/B testing. Let me tell you about a use case to give an example of how Intuit uses that data. We use tax personalization by emitting beacons about all the users' activities when they load pages or they click on buttons. All of those user actions and behaviors are sent across all products and across all platforms and devices into the Intuit Analytics Cloud, where we put it together and allow the product groups to then query that data to analyze the pathing and the navigation patterns of the users and figure out which kinds of actions are easy for users to accomplish, which ones are difficult. And then we define A/B tests to compare different ways of interacting with the application, different paths through a task, and deploy those paths that work best for our users. Now, a couple of remarks about key practices for planning, deploying, and managing the Intuit Analytics Cloud. The first item that I should call out is data security. I already mentioned data security is really important in our business since we're dealing with sensitive financial data from our customers. And we accomplish data security in part by treating each data element according to its level of sensitivity. For the most sensitive data, we may remove or redact that data before we ingest it into the IAC, into the Intuit Analytics Cloud. Other sensitive data we encrypt before users can access that data, and then if they have the appropriate privilege, they can decrypt it and work with that data. Some other data, like public data, we may be able to provide and clear, but we still encrypt it while it's in transport between applications and at rest. That job of making the data secure is facilitated by our data governance team. The data governance team defines the levels of data sensitivity, and they also define how each data element, according to its sensitivity level, should be treated when we ingest it into the IAC and when we process it there. A couple of other areas that you want to look at when you manage and build and provide a data platform for multiple products is managing your metadata and providing committed schemas. For example, if you have multiple products emitting clickstream data into a data platform, you want to make sure that that's done in a consistent way so that you don't end up managing multiple different pipelines doing the same thing. And the same thing is true at the back end when you have multiple product groups accessing that data, and one product group wants enhancement and changes to the schemas that they use at the end to interact with the data. You want to make sure that those changes and enhancements work for all product groups. So again, you can work with a single consistent data platform as opposed to managing many different platforms for many products. Auto-deploy is also a key practice for managing a data platform for a large organization. I can share an example where that became really important for something I was working on. I was working on a Hadoop upgrade. We had a Cloudera distribution, and we were a couple of versions behind. So we had to do a major upgrade across major versions. And there were a lot of breaking changes from the version we were running to the version we wanted to go to. So our product groups naturally wanted to have some evidence that when we do the upgrade, things are still going to work. Because when you go into tax season with TurboTax, you don't want to have any breakage in the data platform. You need to be able to see what's happening with the product, how users are using it. You don't want any interruption there. So if you have a manual deploy of your ingest pipelines and processing pipelines and data services, validating that the data is the same before and after you upgrade Hadoop is a major undertaking, because you have to prepare a QA environment, you have to play the old version of Hadoop, you have to deploy all of your applications. If you want to deploy a number of applications, that's a lot of effort if it's not automated. Then you run a test data set, then you upgrade that environment and deploy the applications again and get the hopefully the same results after upgrading. So you can imagine if you do a manual deploy, that can take a very long time. And if you get differences before and after, you never know, is it because you made a mistake in the installation, or is there something you did wrong manually, or is there actually a problem in Hadoop in the upgrade responsible for the changes? On the other hand, if you have auto-deploy, it becomes very easy. You just push a button, the deploy builds from ground up, from a virgin environment from scratch. You run your test data set, you upgrade, you deploy again fully automatically, and it becomes very easy to validate that your data is the same before and after the upgrade. And that can make a difference from doing that whole exercise in a couple of days or taking weeks or months to accomplish that. One other practice that is also very important when you run a data platform is that you want to monitor your operations. That's because you always want to see any problems with your processing and your ingest before the users see it. For example, you may have a situation where for clickstream ingestion, for example, data from one product platform, let's say iPhone, is not tagged correctly, and then the ingest drops all those beacons on the floor, right? So now you actually want to re-ingest the data later and work with the incorrect tag and still ingest that data. So we had a situation like that, and you want to be able to see, oh, we're actually dropping our beacon volume. So you want to see that before the users tell you that that's happening. What do you want to monitor? The things that you want to monitor are the service level agreements that you have in place, the SLAs. For example, you may have SLAs that guarantee that your data gets processed within a certain latency and not more than that maximum latency. So you want to monitor the timestamps and the processing durations throughout the stages of your processing. And then when you exceed that latency, you want to alert on that. Similarly, you may have service level agreements on accuracy. You may find some unprocessable data items and put them into error buckets, and then you want to guarantee that you have less than n% of data ending up in that error bucket. And again, when you exceed that rate, you want to alert on that. For alerting, we use PagerDuty. We find that very convenient. It allows us to define escalation paths so that when an alert goes out, it goes to one user, maybe an engineer or somebody in ops, and that when that person is not able to respond to that alert right away, it gets escalated to the next person and the next person so that no alerts get dropped on the floor. Another thing that you want to ensure in your monitoring is that you monitor at each stage of the processing so that when you see any problems with the SLA, you can tell that it happened during the ingest, during the first processing stage, second processing stage, maybe during the load into the relational database, and you can pinpoint directly where the error is happening. Now let's look a little bit about Intuit's journey with our big data lake. The first generation Intuit Analytics Cloud is still running on-premise in Intuit's data center and in batch mode on Hadoop. And you may see a lot of talk in the industry when people go to the cloud about lift and shift. So what people mean by lift and shift is you take your application, you deploy it into the cloud with minimal changes, and as much as possible, as is, just lift and shift the whole operation into the cloud. However, what we wanted to do is we wanted to follow the re-architect approach because in addition to moving from on-premise to the cloud, we also wanted to move from batch processing to streaming. So we had two big sets of challenges to overcome, and we're still in that transition. So when you go to the cloud, there's a set of challenges there. First that I would call out is service security. We already talked about security a little bit. When you start using cloud services, it's a little bit of a different ballgame than when you deploy your operations on-prem, because cloud service is in some ways well shut. Like S3, for example, you don't really have control over how the data is stored. Amazon handles that for you, which is great, but you also have less control. You can't maybe choose the encryption methods that you want, or encrypt different things in different ways. There are certain things that are given to you by the service provider. So we have a central security team at Intuit that actually reviews the cloud services and then identifies any gaps or attack surfaces that these services have. And then we work with the central security team to remediate those problems. Sometimes that's easy, sometimes it's difficult, sometimes it's not possible. For example, we make sure that the data that is used in the service is encrypted when we send it into the service, that it's encrypted at rest when the service stores it on disk, and that it's encrypted while the service is processing it and transferring it between nodes. For example, if you use Spark, streaming, and EMR, you want to make sure that the shuffle data is encrypted, for example, when it's persisted to disk. You also want to make sure that there is minimal privilege, so only those users that need to access the data have the ability to access the data. And then when we identify patterns and remediations that are secure so that all of the known attack vectors are remediated, then we can whitelist that service with a certain use pattern. So when you have a whitelisted service and use pattern, that makes it a lot easier to stand up new ingest processing and services on your big data platform. Another thing you have to take care of in the cloud is restacking. For example, your Linux operating system, new vulnerabilities are detected by researchers and attackers all the time. When that happens, new versions or patches are quickly made available for that service, let's say the operating system. And then you running the data platform, you want to restack your processing pipelines and your services as quickly as possible to remediate that vulnerability. Now, we already talked about auto-deploy, so this is where it comes into play again. When you manually need to rebuild your whole pipeline after putting a new operating system image on the box, that is very labor intensive, makes it very difficult to do anything else. If you're very diligent about it, you'll probably find yourself busy just manually restacking over and over, and you can't improve your service or deploy new services. That's why it's important that you think about restacking. Ideally, you might be able to automatically do that, and then auto-deploy your service. And then service monitoring, another thing we talked about earlier. When you go to the cloud, you have an opportunity to improve your service monitoring. Obviously, in an ideal world, you already have all the monitoring on-premise, but in the real world, we're lacking a lot of monitoring where we are. So that gives you an opportunity to re-architect your monitoring and make it more complete as you go to the cloud. Other set of challenges come when you go from batch to streaming. Maybe the most important challenge here is stateful processes. I'll tell you a little bit about what I mean by that. Let's talk about clickstream ingestion. When you get clickstream events from the internet, from different users using different products, you want to sessionize that. You want to figure out, which of those events happen in the same session. Then the user goes away for, let's say, 30 minutes or more, and then you start a new session. So if you do that in a batch world, that's pretty easy, right? Because you have like an hour of events, or maybe even a day of events. You just sort the events, and you know the context of the event and when you have to start a new session. But when you go to streaming, you see each event individually, right? So now it's harder to tell, like, is this a new session, or does it belong to another session, or what is that session? So you need to manage that state. So you need to cache that information or put it in a key value store like Cassandra to be able to identify the sessions. In my mind, much more difficult than in a batch world. Another challenge is performance. For example, when you work with Spark streaming, there's a new set of challenges that you have to learn when you adopt Spark streaming. You have to figure out what's the optimal micro window size. Do you want to do half a second windows? Do you want to do 5-second windows? Do you want to do 3-second, 1 minute? It's not really clear. You have to experiment. You have to figure out what's the optimal number of nodes that you want to use. You have to partition the data so that you avoid excessive shuffling. A lot of things to think about. Elastic scaling is a big opportunity when you go to the cloud, and ideally you have the ability to just add additional nodes to your processing cluster to deal with higher volumes of data. That becomes possible in the cloud, but it's a new challenge. You have to think about how do we do that, and to make sure that when you add those nodes, your architecture can actually benefit of that. Then in the streaming mode, replay also becomes more difficult. We already talked about that there could be issues with the source data that you ingested, or maybe you have a version of your pipeline deployed for a little while that had a bug, and you want to replay some data. If you replay a batch of data, it seems pretty simple, right? You just rerun the batch and you're done. If you do that in a streaming world, then you actually need to checkpoint the state of the application throughout the day, and then you need to find the right checkpoint, the last checkpoint before you want to start reprocessing. Then you have to bring that checkpoint back, restore the application state, and then you have to restream all the events to reprocess them. So that's a little bit more involved. And then lastly, event ordering can also be a big problem. When you process a batch of data, let's say an hour of data, you can just sort the events, and you know that the events are sorted. When you get each event individually, then you cannot be sure that you're getting them in the right order. So you have to either choose frameworks that guarantee event ordering, or you have to make sure that your application can tolerate some errors in the event ordering. So for example, when we did the analysis for online sessionization of data in a streaming mode, we analyzed our event data, and we actually figured out that there's just a very small number of events that users generate after about 30 minutes of inactivity, which would define a new session. And in fact, that's so rare that users just start to be active exactly after 30 minutes that we found that the error rate would be just 1 in 80,000 sessions that would be defined incorrectly, because the user just happens to be active before 30 minutes expire, but the event comes a little bit late, so we incorrectly start a new session. Let me also show you a couple of architecture diagrams that show you how we're building the Intuit Analytics Cloud. First, if you look at the purple bar at the bottom, that is our storage layer. We call that Storage as a Resilient Service, or STARS. And that's a wrapper around S3. What that wrapper provides is the ability to compress data, to encrypt data, to manage the access to that data, and also to make sure that when we send data into S3, that it goes into the right bucket and that it's properly structured, so that it's consistent for use in the data platform. So those are a few value-added services that the STARS wrapper, STARS component provides on top of S3. Then if you look up from there, you see a number of components in our compute framework. First, you have the real-time ingestion component, which is the RTI component here. And the next slide will show you more details on how we do real-time ingest in that cloud, which provides patterns for real-time ingestion of clickstream events, application events, relational data, and file data. Then if you move to the right, you see a transform component. So you can either stream the data from the ingest to the transform component, or you can persist the data from RTI into STARS, into S3, and then you can transform the data in batch mode on top of that. Then after we enrich the data and augment it with additional information, we load some of that data into relational databases. So our users can then do reporting and dashboarding and deep dives on top of that data. By the way, I should mention that this architecture is still under development. Some of those components have been built, some of those components we're working on, and some of them we're planning to build into the future. But if we look to the right of the compute framework, you see compute as a service. And that gives our product groups the ability to spin up Spark clusters and then operate on top of our data platform, either in streaming mode, and I'll show you a little bit more how that works, or on top of S3 in batch mode. Lastly, if you look all the way on top, you have a component for workflow and replay management that gives you the ability to define new workflows. For example, to add additional click streams for new products that may come online. And then the ability to manage replays so an operator doesn't have to edit a bunch of files and do the replay manually. So there's a little bit of support for that. And then lastly, there's a self-onboarding component that would allow the product groups to onboard new data streams onto the Intuit Analytics Cloud themselves without spinning up an engineering project to accomplish that. Now look at the real-time ingest framework. There's 3 patterns here. If you look at the left side, there's relational data. Then below the relational data, there's clickstream and application events. And below that, you have files. Those are the 3 patterns for ingesting data, or 3 types of data that we ingest. Then we have a big box for the ingestion and processing. And then to the right, we have ways to access the data through Spark Streaming, Spark Batch, or through relational databases from top to bottom. Let's look at how we ingest relational data first. So we ingest the relational data by trailing change data capture events. For example, Oracle provides Golden Gate, and you can then have a log trail of change data capture events. And those events are things like insert row 15 into table A, or delete row 36 from table B, or update a certain row in a certain table. Those are the change data events that we handle here. What happens is that we put those events into our event messaging service. The event messaging service then create Kafka queue message items, and the payload in those messages is the change capture event. We then collate those events and persist them in S3 in our stars component. And from there, we then pick them up and kind of rehydrate the database content. We rematerialize the database by looking at the change data event for a certain table, certain row. We figure out which S3 object has that table and row in it. Then we make the change to that row as indicated by the change data event. And then we write that shard back. So that means that after handling a batch of changes, we then have the updated status of those tables in S3. And we can run Spark batch processing against that to run processing in Spark and S3, just as if we were able to run those processes and queries against the source database. Now, if you look a little bit down, you see the ingest pattern for clickstream and application events. It follows a little bit of a similar pattern, uses some of the same infrastructure. So first, we have an event ingest SDK, a software development kit, which provides a library that allows our product developers to emit events into the Intuit Cloud. And those events then hit our event messaging service. And the event messaging service, again, creates Kafka messages. So for example, when you interact with TurboTax on your mobile phone, then there are instrumentations in that code that send beacons to the Intuit Analytics Cloud. And it would identify who loaded the page was it, what product was it, what device was it. And we can then make inline transformations on that data. For example, we can map the IP to the geography, or we can map the user agent string to information about the device. And then our users can then run Spark Analytics in a streaming fashion against a processed data topic in Kafka. So data comes in, gets persisted on a raw topic. We do some augmentation of the data. We write it back into Kafka in a process topic. And our product groups can then do analytics on top of that data in real time. And that allows them to do things like personalization. They can see, for example, oh, this user is getting stuck. He is querying help a lot. He's trying to fill the same form over and over. He's not being successful. Maybe we want to pop up a chat message and help that user. Or we can do things like fraud detection. We can say, oh, this pattern looks like a fraudulent user. So we can do things to block that attempted fraud in real time. Then if you follow from the Kafka queue, going to the bottom right, you see that we also collate those events and persist them in S3, which allows us to have a persisted version of both the raw data and the processed data in S3. And we can run to the right in the middle Spark batch processing against that event data. And then lastly, if we look at the bottom left, you see the file ingest pattern. Again, we have a file ingest SDK, which is a library that allows our product groups to emit files into our Intuit Analytics Cloud. That data is then by the library written into S3, into the appropriate bucket and in the right structure. We then monitor the arrival of those files and create a queue of files to be processed. The files are then processed and transformed, and the transformed data is written back into S3. And we can again run Spark batch processing on top of the transformed or on the raw data. For all of those ingest patterns, we also load some of the data into relational database with the MPP load box at the bottom right. And we use Vertica for that mostly, so that our users can then, regardless of the type of data, on relational data, application data, clickstream events, or files, they can perform analytics, they can run reports, they can create dashboards, and they can also do deep dives on top of that data with a single mechanism. All right, here's an example of one particular ingest pipeline for the event processing pattern. So this is for our TurboTax mobile and tablet devices. You see on the top left, in the green dots are different devices on the internet. The product is instrumented to emit beacons with the web and mobile SDK. Those calls will then go into an elastic load balancer. The elastic load balancer will will go to a Jetty cluster, and the different nodes in the Jetty cluster will feed different partitions in a Kafka cluster. So that's the ingestion part. Then in blue, we have the processing part. We have Spark streaming, and we have Spark being a consumer of raw topic in Kafka, and then processing those events, augmenting it, like I mentioned, for example, mapping IPs to geographies and mapping user agent strings to devices. And then we can extract the payload out of those events. We can do business logic transformations and augment that data, and then write that stream back into a process topic. Then both the raw and the processed beacon stream will be persisted in S3. And then if you follow down and to the left, you see that we are then writing and loading that data into Vertica for reporting, dashboarding, and deep dives. There's two different steps involved here. The first one is format conversion, because we have beacons that are generated by Intuit SDKs. We also have instrumentation for Omniture. So we transform the formatting so that we can use a consistent format for both sources. And then we have an Intuit created tool called Dragline, an internal tool that lets us load that data in small batches into Vertica. That's important because if you try to load a stream of events one by one into a relational database like Vertica, and you have millions and billions of events going into Vertica as inserts that will bring down the database. So you need to first batch it and insert small batches into the relational database. All right, the last slide I wanted to share with you is an example for our file ingest architecture, one particular pipeline that uses the file ingest pattern, and that's for tax files. We traditionally were in the past ingesting that data via FTP. You see that on the top left, and with an X, because we're not doing that in the new style of processing. We're using streaming to ingest the data. We extract the text data from a relational source. Then the BU, you see the the product group's processing in the big blue box on the left. The product group remediates the data. They eliminate the sensitive data, and then they emit that data into S3, into our stars storage component, using stars file ingest SDK. And that stars file ingest SDK handles the authentication with Amazon and compression and encryption. Then we monitor the new files arriving in S3. There's different ways of doing that. You can do that either with SNS notifications, or you can do that by using the S3 list API. And that creates a queue of messages that identify files that need to be processed. Then we have a Spark streaming cluster that processes those messages. That means for our tax files that we parse the XML. We generate key value pairs. So the key identifies where in the XML the value occurred, and the value is the value that you find there in the XML file. Then we filter those key value pairs to throw away some of the values that we're not interested in, and we persist both the raw data and the processed data into S3. Now again, we use the Intuit internally developed dragline tool to batch up those key value pairs that we actually want to insert into Vertica, and we insert that into a Vertica staging area. And then the BU, again shown in blue, the product group on the right can take over, and they can use those key value pairs and build a data mart. And then they can run their reporting, dashboarding, and deep dives on top of that data mart in relational form. So those were the two examples that I wanted to show you of how we implemented particular data pipelines using the patterns that I shared earlier that we defined for the Intuit Analytics Cloud. I'd be happy to take a couple of questions if we have time for that. Looks like we have just a little bit of time, yeah?
So when I fill my tax forms on the desktop version, how's the data being stored? Is it documents or actually going to eventually when you upload it into relational data store? Because you mentioned a lot of relational.
Yes, so the government wants to receive the data in XML. And that's how, if you use Intuit to submit your data to the IRS, it gets submitted in XML. And also, the TurboTax application uses XML as an internal storage format. The formats are a little bit different. But if you use your desktop version, then those files are stored on your desktop. They're not sent every time you save to Intuit or the government. They're just kept on your desktop until you submit it. Yes.
For these jobs, what are you using for your scheduling and workflow needs?
For scheduling and
Workflow?
workflow?
Yeah, workflow scheduling.
Yeah, that's an interesting question. So we have some jobs that run with Zookeeper. We also have older jobs in the on-prem implementation that use Tidal. But scheduling is something that we find we would love to have better solutions. We looked at a couple of different solutions, and we're using some different solutions for different pipelines. But I can't really tell you that I have the perfect answer there. It's something we're still working on. Yes? I'm sorry?
The MPP data warehouse,
Yes,
you guys using vertical,
yes,
not Redshift.
yes,
So it's, the vertical is also running on database.
yes, yes. Good question. So the question was when we use relational data stores to make the data available in relational format at the end, do we use Redshift? Do we use Vertica? Are we able to run Vertica in the cloud? And the answer is that we've been using traditionally more Netezza, then we've been transitioning more to Vertica on-premise. So now the next step for us is to run the Vertica in the cloud. That's something we're working on at this point, and then possibly eventually migrate to Redshift. So again, that's an ongoing process, and we're looking at different options of doing it. And we're using different data stores depending on when we created that data store and what our preferred platform was at that time. Yeah.
Have you done any benchmarking between Vertica and Redshift?
No, we haven't done that benchmarking yet between Vertica and Redshift. I've used Redshift in a previous company where I was before Intuit. And that was maybe 3 years ago. We found that Redshift had a few shortcomings, particularly when it comes to data schema definition. It wasn't fully complete. I think it's made a lot of progress since then, but we haven't done any benchmarks lately. Thank you very much.